shot put is a complex power movement that involves the body segment's sequential energy transfer through translational and rotational movement. In other words, the shot put can be described by analyzing the flow of energy translated through the body. Performance in the shot put is largely dependent on muscle power production, which is the product of force and velocity of the movement. In other words, by using the big force-producing muscles in the quads, which are the vastus lateralis, vastus medialis, vastus intermedius, and rectus femoris, the goal of this movement is to generate as much force as possible and translate that force using the concept of conservation of energy to maximize the shot put distance.
The objectives of the shot put is to release the shot at the maximum forward velocity at an angle of approximately 36 to 37 degrees above the horizontal. With all shot put styles, the objective is to reach the highest rotational body speed possible to efficiently transfer energy to the shot put and maximize the distance of the throw. This action of maximum rotational velocity and sequential energy transfer, along with the proper projection height, maximizes the throw distance of the projectile, which is the shot put.
According to a study done by Ballard Judge in 2013, there are several biomechanical advantages and disadvantages for both the glide and spin techniques. In this study, we will focus on the glide technique. For the glide technique, research indicates that the most successful biomechanical advantage was exhibited by those athletes of bigger size, which included both height and weight and the strength of the respective athletes. Higher projection height due to taller athletes is desired. However, maximizing projectile height is only advantageous when maximum velocity and power are maintained. Overall, the goal is to maximize velocity and force production at the highest appropriate projection height and angle, while not compromising the speed and power to achieve the maximal horizontal distance traveled of the shot put. Therefore, this study indicated that the gliding technique might be better utilized and provide a biomechanical advantage to those with greater raw strength and increased size in both height and weight. Another characteristic that greatly influences the shot put movement is muscular power. Power can be defined as the mechanical quantity that expresses the rate of performing work and is mostly dependent on an athlete's ability to exert the highest possible force over the shortest amount of time. Specifically, muscular power is mainly determined by the amount of muscle mass and the fiber type making up the muscles. In a study done by Nicholas Zaras in 2016, it was determined that muscle thickness, fascicle angle, and fascicle length can be altered using heavy resistance and power training. The point of the study was that after the shot putters trained using heavy resistance training, they not only increased their 1 rep max strength, but they also increased their vastus lateralis thickness and muscle mass, which resulted in an increased rate of force development, which inevitably resulted in farther shot put throws. In order to showcase this biomechanical concept, we have broken down the shot put into 4 different phases: the gather phase, the glide phase, the delivery phase, and the release phase. In the gather phase, the goal of the athlete is to create a position of power and maximize potential energy in order to best start the explosive movement of the shot put. Often overlooked, the gather phase is vitally important when it comes to setting up the beginning of the throw. Maximizing the potential energy in the gather position eventually increases the efficiency of the translation from potential energy into kinetic energy during the subsequent movement phases of the shot put. To begin, it is vital to have proper hand placement in order to maximize the end of the shot put movement. The shot put should be placed on the palm side of the hand, right above the center of the palm. Common mistakes of hand placement include what is termed palming the shot, in which the shot rests directly in the center concave surface of the hand. Palming the shot reduces the follow-through at the end of the shot put movement and reduces the throw distance due to reduced velocity of the shot as it leaves the hand. Additionally, resting the shot correctly toward the fingers allows the athlete to maximize the height of projection and allows full flexion of the fingers during the final phase. In addition to hand placement, Part of the gather phase includes shot placement in preparation for the throw. The shot is to be placed securely below the mandible, making certain to keep the shot put tight against the neck in order to reduce energy-wasting movement and ensure uniform linear movement. The humeral ulnar joint of the throwing arm should be almost fully flexed, and the glenohumeral joint should be abducted at an angle of approximately 45 degrees. The radiocarpal joint or wrist should be hyperextended slightly. To prepare the lower half of the body, the shoulders, hips, and toes should be pointed toward the back of the ring, making sure everything is aligned properly. All the athlete's weight should be on the lead leg, in this case the right side, with a fully extended hip and knee. The left toe should be about a shoulder width behind the lead leg with only slight weight on the ball of the foot. The knee of the back leg should be flexed at approximately 120 degrees of knee flexion or flexed to the athlete's comfort. In order to maximize the kinetic energy and momentum of the shot put movement, the first step of the gather is to raise up onto the ball of the foot by plantar flexing the ankle using the gastrocnemius. This slight counter movement is key to maximize the height of the body in order to maximize the coiling potential of the body. After reaching maximum height, the shot putter immediately drops the lead leg heel and slightly flexes the torso forward so that the chest is over the toes. Continuous with these movements, the athlete flexes the hip and knee of the lead leg simultaneously and draws the back leg quickly to the chest in a coiling motion. The goal of this movement is to maximize the strain potential energy of the leg muscles in preparation for the explosion and translation of the strain potential energy to kinetic energy. A common mistake in the coil and gather phase is to leave the lead leg in an extended position and bend at the back. This movement does not allow the athlete to build the strain potential energy in the legs, which is the source of the power movement.
The glide phase begins with the athlete in the coiled position. The first movement is for the athlete to dorsiflex the ankle and rock back, also called unseating, with the athlete moving towards the front of the ring, leading with the gluteus maximus. The rock back phase should continue until the athlete's gluteus maximus reaches the center of the ring. At this point, the left leg that has been coiled to the chest forcefully extends and swings through at the hip in a kicking motion to assist the athlete across the ring to the front of the toe board. As the left leg extends and kicks back towards the toe board, the athlete simultaneously pushes off the right heel to temporarily go airborne in an effort to efficiently cover the distance to the toe board. It is important to note that this gliding motion should be as linear as possible with no lateral movement of the chest and shoulders or of the shot put itself. The end of the glide phase results in the athlete forcefully flexing the tibiofemoral joint or the knee joint using the hamstrings to allow the athlete to land balanced with the majority of the weight on the lead right leg with toes pointed slightly greater than parallel to the toe board. The feet should not land simultaneously, as this error decreases the momentum of the glide movement. Instead, the right foot should contact the ground only slightly sooner than the left foot in close succession of each other. The toes of the left foot should be aligned with the heel of the right foot, preparing the lower limbs for maximal hip rotation. The chest and shoulders of this final position of the glide phase should continue to face the back of the ring, creating increased torque in between the hips and the shoulders in preparation for increased rotational velocity. At the end of the glide, the athlete should be in what is known as the power position. The power position is the position where the body of the shot putter is at maximum torque. This is where the body is preparing for the angular velocity of the delivery phase.
The delivery phase begins in the power position with staggered feet, loaded hips, and shoulders still facing the back of the ring. The non-throwing arm is fully extended, reaching across the sagittal plane to the opposite side of the body, pointing toward the back of the ring. The first movement of the delivery phase is the simultaneous flexion and horizontal abduction of the glenohumeral joint or shoulder joint of the non-throwing arm. This action is designed to force the shot putter to open up the chest and push for height, which maximizes projection height. A common error for gliding shot putters is to only horizontally abduct and flatten out the movement of the shoulder joint of the non-throwing hand, resulting in a flat and downward projected chest. This limits the height of the projection of the shot put and consequently limits the distance of the shot put. The second part of the delivery phase is to extend the weight-bearing leg at the knee using the quadriceps with emphasis on the vastus lateralis, while simultaneously beginning to push upwards on the shot put. The key to this movement is to simultaneously complete these two movements due to the fact that staggering these movements results in less power and explosion and decreases the resultant velocity. As the athlete reaches maximum extension of the weight-bearing leg, the linear velocity begins to translate into angular velocity. Keeping the weight on the right leg, the athlete rapidly rotates and extends the hips with maximal angular velocity, making certain the extension of both the hips and chest is upward in nature. In addition, the right ankle plantar flexes to push the hips forward to achieve maximal extension and increase power and explosion. Common errors in the delivery phase is to transfer the weight to the front left foot. However, doing this decreases the power generation of the angular velocity and diminishes the throwing distance. Additionally, many throwers force their chest and hips in an outward direction instead of maximizing the upward trajectory of the movement, creating a biomechanical disadvantage.
The release phase begins at the moment of full hip extension, when the left arm and leg simultaneously block or immediately translate the angular velocity back into linear velocity in the direction of the sector. The block of both the non-throwing arm and the left leg work together to abruptly translate angular velocity into linear velocity while thrusting the right hip and shoulder forward to maximize the range of motion of the movement to maximize the power generated by the movement. Specifically, the block of the non-throwing shoulder is flexion of the elbow and extension of the shoulder, while the left hip is forcefully pulled dorsally. The last movement of the release phase is to horizontally adduct the throwing shoulder and to extend the elbow of the throwing arm at a projection angle of approximately 36 to 37 degrees. Finally, at full elbow extension of the throwing arm, the fingers flex forcefully, pushing the shot put off of the hand at maximal velocity. We have discussed the four phases and biomechanical movement of the shot put. However, analysis of this skill would not be complete without mentioning the methods of how elite and novice shot putters are increasing their throwing distance using biomechanics. As we have mentioned before, shot putter performance is mostly determined by strength, power, and technique. According to the performance study done in 2013, the skill of shot put utilizes a highly technical sequence of movements that attempts to create a summation of forces by creating torques between different parts of the body. These torques on the body work to create force and power in a rotational direction in order to transfer maximum velocity to the shot put implement. Due to the explosive nature of the shot put and the complex and sequential technique that must take place, specific training programs must be designed to emphasize strength, power, and flexibility in shot put athletes in order for them to be successful. Other than the actual technique of the shot put skill, strength training is the foundation of success in the shot put event. In the 2013 study, researchers determined that power movements like the power clean resulted in the best increase of throwing distance for elite shot putters due to its focus on maximum power produced over the shortest time frame. The reason strength is so vital in the sport of shot put is because it is necessary to accelerate a mass, in this case the shot put, and achieve the desired high velocity, impulse, and momentum. In other words, this study revealed that the stronger athletes are able to hold the positions necessary to master the shot put technique. Optimal technique, as mentioned previously in the phases, is the key to producing the maximum acceleration and therefore maximum distance of the implement. Overall, it is evident that shot put is a highly complex movement, done through a combination of linear and angular velocity driven by power and torque.